This is our third lesson this week, and today we're going to learn about another force called electrostatic. Now, electrostatic, I'm sure you've heard that word before, but you're not sure maybe when and what's that to do with it. And I'm sure you experienced that force before. So, in fact, that force is probably one of the most important forces there. It's what makes, for example, this solid, okay? So you know I can't go through a solid. It's because of electrostatic force. Okay, why? That's a different story, but you just know that everything that makes, why we can't go through materials except for gas is because of electrostatic forces, okay? Now, some cases where you really experience that forces, so imagine a hot, berg wind, very dry day, and maybe you walked around, and then you came to your car to open, and as you got very close, you suddenly got zapped, okay? That's an electrostatic force. It's because of electrostatic force. Maybe you're jumping on the trampoline on a hot summer day, and then you come off to just get off, or you touch a frame, and suddenly you've got the little zap. That's an electrostatic force. So what is actually happening? Okay, I'll show you a couple of demos, and then I'll explain. Well, I'll do a bit of everything, but eventually you will get notes. So what you need to understand that there are two kinds of electric charge. They're positive and negative charges. Positive charges, negative charges. Now, we already learned about that really in the atom, where we said that the electrons have a negative electric charge, and the protons have a positive electric charge. Okay? So, these are the same electric charges we're talking about. Okay? And the forces between them, that's what we call the electrostatic force. So just like in the magnet, where we learned that the North Pole attracts the South Pole and the other way around, opposite poles attract, a like pole repel, it's the same with electricity. So two positive charges, two negative charges will repel each other, but a positive and a negative charge will attract each other. So I'm going to show you now a bunch of ways you can see it in daily life, and to some extent we'll explain some of them, but not wholly. So you could do that at home. You just need some kind of ruler, okay? And you need some kind of cotton wool. You can use maybe your jumper. You can just experiment with different things. And you just rub it. And what we do, we're rubbing it, we're actually peeling off some electric charge. So we're getting rid of some electrons, some negative charges. They either go from the ruler to the cloth or the other way around. I don't know which one it is, but we have some kind of transfer of electric charge from one insulator to another. We have to work with insulators here. Now over here you can see I've got little bits of papers that I just cut in before. And if I get it close, you can see they attracted it as if they are magnets. Okay? And you feel that sometime in the summer where you feel like your hair on your hands rising, okay, on a berg wind, and then you might get a zap. Okay, I'll just show you again. Fantastic. Okay, I'll explain what actually happens there a little bit later. Now, this is something that you might come across later, maybe in grade 11 or 12. It's called an electroscope. Okay, I'll pull it a bit back. And what you've got here, you've got a metal dish connected to this metal rod. And inside, I don't know if you can, you should be able to see there's like a metal leaf, a very, very thin and light metal leaf. Okay, originally it was supposed to be golden leaf, but here I don't think it is. Okay, now look at the metal leaf. When I, again, charge my ruler, okay, I'm peeling off some electric charge, and I get it close, you can see that the leaf goes away. Okay, maybe I'll explain already what's happening now. So let's say I peeled off some electrons. Some electrons went from the ruler to the cloth. I peeled them off, just like I can peel butter. Okay? So now if I lost electrons, if there's less electrons on my rod, that means it's positively charged, right? Because if I lost a negative charge, that means it's more positive. There's more positive charge than negative charge, so it's net positive charge, okay? Now if it's positive charge, that means it attracts electrons. So that means all the electrons here that are just all over the metal will start going upward, attracted to that positive charge. But it means that all the electrons start flowing upward. That means that over here, over here we have more negative charge, but that means over here we have more positive charge. So if there's more positive charge, okay, the leaf will be repelled by the metal, the heavy metal here, okay? So both of them are going to be positive, okay, and therefore they repel each other. We use a leaf, a very thin metal, that the electrostatic force in this case will be stronger than its weight, okay? There's one more case that I want to show that to you, so I'll just pause here. Okay, so this experiment you can also do at home, and what you're going to do is just let some water run. You want to have a very thin stream, okay? The thinnest you can have, but not having drop. So it doesn't need to be, it shouldn't be drip. It just need to be a thin stream, the thinnest stream you can. And then you charge your ruler again, okay? You get some extra charge, and then let's see what happens when you put it next to the water. Okay, I don't know how well you can see it, but I can see really well that it just bends the water. Really bends the water, okay? Like it was a magnet, okay? I'll do carry on this video on the board and we'll explain what's happening. Okay guys, so what you need to know for the test, electrostatic force, you need to know that there's two kinds of charges. There's positive charge and negative charge, okay? There's two kinds of charges. Well, if you have a positive and negative charge close together, they will attract. Okay? If you have two negatives or two positive, they'll repel each other. The second thing you need to know, and I will make you a little question like a fill in the gaps activity for the lesson, is that if you take two insulators, so that was like the ruler and the cloth, okay? If you rub two insulators together, electrons, it's always the electrons will move from one insulator to the other. It's always the electrons move, the protons don't. Okay, so negative charge will move from one to another. You can't really tell from which material it moves. It depends on the material. Now, when we do that, what we're doing, we're charging both insulators. So now, the ruler, which lost some negative electrons, will be positive charge, and the cloth will become negatively charged because they have extra electrons. Now, if I take that ruler, which is positively charged, and I put it close to the bit of paper, it's the same thing with the water. With the bit of paper, remember it attracted it. Why is that? Because the bit of paper, it's neutral. It has equal number of positive and negative charges. But the negative charges will be attracted to the positive charge on the ruler, so they'll move up a little bit. That means that the positive charges will stay behind. And we have something, we don't need to know that word, but I might as well just say it now. It's called a dipole. Dipole, like a pole, like a magnetic pole. You'll have a positive pole and negative pole. Now, the negative side will be attracted to the positive ruler, but the positive side will be repelled. So we're going to have two forces. We're going to have attractive forces towards the ruler, and we have a a repulsion force pushing it away. But now what we saw, when I did that, it got attracted. So that means that this attractive force is stronger than the repulsive force. That's why I drew it bigger. But why? Can you think, why is the attractive forces bigger than the repulsive forces? And I think if you think about it a little bit carefully, you'll realize that it has to be stronger because the negative charges are closer to the positive charges than the positive charges. Okay? So the negative charges here are closer to these positive charges than those to them. So it's like you have two magnets, one repelling, one attracting. Okay? But the attracting magnet, the attractive force, is stronger because it's closer. Okay? So hopefully that makes sense. So what I would like you to do now is add to these notes the little activity to fill in the gaps that I'm going to give you underneath this video to make sure you understand this whole topic. See you guys next week live in the classroom. How cool is that? Bye-bye.